heaven. Give us today our daily bread. Forgive us our sins, as we forgive those who sin against us. Do not bring us to the test, but deliver us from evil. Amen.
Thank you, Vamika. And next, we got an eminent personality today. Up to you. I welcome you personally to this webinar.
Thank you so much. Thank you all. And thanks for calling me here. I hope you can hear me clearly.
Yes, sir.
Okay.
Loud and clear.
Okay. So I extend my uh, hearty congratulations to all of you for organizing this program where you are commemorating the landing of the moon. And I feel landing of the moon is something to be really celebrated because there are several reasons for it. Normally, we attach and associate so much of romanticism with the moon that we really do not look at the scientific issues involved in this whole process and the whole endeavor. And we have the wrong notion that quite often we feel in one summer morning, three astronauts just packed their bags, got out, and had a vehicle and reached out to the moon. It's exactly as simple as that. And we attach so many things with it, and that a special Neil Armstrong statement that gentle step for a single step for a man is a giant leap for mankind. That also romanticizes the whole thing. But I'll try to show you how difficult it was, how challenging it was, because so many issues were involved and so many people were involved in it. It was not easy. It was not like going to any other place on the earth. And why at all go to the moon? Is it just a luxury? Is it just because we have plenty of money and nothing to do so we can go there? But what is the purpose? What do we achieve out of it? And what do you still want to do with the moon so that many countries are still trying to reach out to the moon and make a soft landing there, make a food base there? What are the reasons? I'll try to show all these things a little bit. But before that, there is a preamble, how this whole thing happened, how it came to be. So please allow me a second. I'll just share one presentation with you and then get back to the whole story. Just a minute. Can you see the presentation?
Yes, sir.
Is this slide changing?
Yes, sir.
Okay, great. So let us get into this story. I call it Moon, the gateway to stars, and I'll try to amply explain why I call it so. Why I call it the gateway to stars. It's not exactly, there is still a little romanticizing here also. It's not really the gateway to the star, but of course the gateway to the space, to the outer space. And why so? I'll try to explain all that. The question is, was Moon a very natural destination? Were the human beings thinking of going to the moon long back? Or is it just this phenomena that 1959 it happened? Is that so? The point is, even though there was no means to go to the moon and we did not know what to do to go to the moon, we still had the, not the objective, I would say, but still the romanticized idea of going to the moon, because people thought that the moon is something very interesting. The sun was always seen as a very strong and powerful and very hot thing. People understood that. So there were not much stories or not much attempts to go to the sun, or at least imaginations to go to the sun. But regarding moon, it was not like that. It was always the center point of our imagination. And you all know that recently there is a lot of interest in going to the moon. India is trying, China is trying, there are other countries which are also trying. Of course, the US is always there around, so is Russia. So why this interest? We will try to see. But the problem is when we do science, quite often we get swayed away by the science fiction. So we talk a lot of stories and we feel that these are all dramas and theaters, but exactly not like that. There are scientific issues involved. Let's get into that. Well, the first imagination of going to the moon started in probably 10th century. When there was a story, it was thought that a moon princess grew up on the earth as the daughter of a woodcutter and his wife. But somehow later on, the emperor was impressed by her beauty and wanted to marry, which landed up into several troubles. And this story says that the princess returned to the capital of the moon. The story is not an important part here. The idea is that people thought you can go to the moon and you can also return. I mean, that was the real challenge in it, the challenge of imagination. So this shows that even from that time, people were thinking at least of going to the moon. Then there was another story in 1516. It's a long jump, but still, in that story, once again, it's called the Orlando Furioso. There was another story, and it was thought that one person on the earth, he lost his wits and lost his senses because he was in love with that was thoughted. So he was breaking up everything on earth, just losing his wit altogether. And then one knight had to go to the moon, and that story incorporates a very interesting idea. It says that whatever you lose on the earth, you get back in the moon. So since this man lost his wit, the knight had to go to the moon to recollect his wit and senses. And when he came back, he gave that to this man, and the man was restored to sanity once again. Well, that's this story. But once again, here, the moon princess probably was imagined to take a single way journey. She went to the moon and that's all. Then there's no mention of any other way out. But in 1516, the return was also incorporated. So the man, the knight, Astolfo, he went to the moon and came back. So that means the possibilities at least were in the realm of thinking. Then in 1865, things are getting concretized a little more, crystallizing ideas. People could understand that it's not easy to go to the moon. It will need a vehicle. It will need some elaborate engineering also to be handled and tackled. And that is why when From Earth to Moon in 1865 and its sequel Around the Moon in 1870, these were written by very famous science fiction writer Jules Verne. When he wrote all that, he thought of projectiles. He thought that something needs to be thrown up and you need enormous energy to go to the moon, because by that time we were grasping the physics of it. We were slowly understanding what will it take to go to the moon, but not quite, because it was pretty much a different dimension of challenge altogether. But still, they understood that an elaborate engineering would be needed. And when in 20th century we have made that story into a film, there we had all this associate paraphernalia. I mean, the equipment, the contraptions. We now know that there should be a launcher, there should be some shape exactly of the vehicle which is needed to overcome the resistance of the atmosphere, and the pull of the earth needs to be negotiated. So naturally, a huge energy will also be required. So all that thing came here in this discussion. But well, a more realistic point of view was taken by A.G. Wells when he wrote the book First Man in the Moon, even though it was not quite exactly the method that we follow. He thought that the vehicle that will go to the moon would be covered by a special material which can prevent gravity, and the vehicle will automatically float over the gravity and can be steered towards the moon. But not only that, he also thought that moon was habitable, and there were animals, insect-like creatures who were called cavor. They are inhabiting there, and they met the men who went to moon from Earth, and they did not have very interesting and very cordial reception over there. So anyway, these things were going on. And then in 1950, one Belgian cartoonist, probably some of you at least have heard of Tintin, and Tintin's creator Harge, he thought that Tintin was an explorer and an investigator, though he was by profession a journalist, a young boyish type of character. But his creator thought that it would be nice if Tintin can go to the moon, and there he imagined, here you can see that everything, the launcher in its detail and the rocket to a large extent of detail is presented in this story. But even at that time, there was no real discussion of going to the moon. But Harge thought in 1950 that not only Tintin with his two other colleagues, two other colleagues and one dog has to go to the moon, but he also thought that this vehicle will have several parts and several details. He made an engineering drawing of that. These were also imaginations, no real rocketry, no real experimentation for going towards the moon was still in place. Rocketry started somewhere in 1940s, but it was not still in a condition where people can think that it will cross over the gravity of the earth and will reach out to moon. But even then, in imagination, Harge made Tintin to land up on the moon, and probably in the modern era, he would have been the first man-like character imagined on the moon's surface itself. Before Neil Armstrong, he probably landed up there. But that's a story. And then in Explorers on the Moon in 1953, it actually happened. They reached out there, they talked about it, they did many things and came back. But that is not our concern right now. Now we are going to get into the real objective, the real issue where we need to go to moon. One explanation for going to the moon was very nicely given by an artist. He was a craft maker, Araki, in 1984, when he said that if God intended man to be a spacefaring species, he would have given us moon. And actually, we have the moon, whether the God or no God. The issue is we have a moon, and that is a very impactful thing for our spacefaring. Without the moon, probably the motivation would not have been there. Let's see a little bit how it really started. When the spacefaring started, and the countries, America and Russia, both were very powerful, and they were trying to conquer this space, and it was a kind of war of pride that who will do first things in this space. They were both sending vehicles, but Russia first sent a manned mission to space, not to the moon, but to outer space. A vehicle went out with a man and then it returned. And America thought that that is a very, very big uh, jolt to their sense of pride. And that is why in 1951, the American president called conference of the scientists to decide how appropriately it should be replied. And there, after a lot of deliberations, when others thought of several other means, the American president wrote down a vision plan for this project, and he said there should be a man on the moon at the turning of the decade. So one decade, 10 years time period was fixed in 1951, and they thought that before the turning of the decade, man should land up on the moon. Yes, at that point of time, it was not really the scientific objective that's given prime importance. It was a kind of fight between these two countries of the battle of supremacy in this space that really resulted in the attempt of this project. But later on, the whole thing changed, and I'll come to that. Now, looking at this image, quite often it may appear that it is actually a photoshopped image, but it is not. It's a real image taken by one satellite, one of our satellites. It's called Discoverer. And this Discoverer took the image at a time when it was behind the moon. So the moon here, we are seeing that is not the moon that we normally look at when we look at the sky, because you all know that moon only presents one surface to us. This is the other surface that does not turn to us really. So why did I show this is because by seeing it, you can understand how it looks from this space and what it takes to go to the moon. The idea is when the moon will rotate in its orbit and will come closer to Earth, one projectile will be shot from the Earth and it will reach out to the moon in appropriate position. But think of this situation. It is almost 4 lakh kilometers away, and it is moving at a very high speed. So is doing the Earth. The Earth's orbital speed is very high, and not only that, it is also rotating, it is spinning around its own orbit. So whatever projectile you throw from the Earth, that will carry the history of motion of the Earth with it, and it has to reach out to the moon 4 lakh kilometers away, and there it's not that it can reach to a train station or a bus stop where once we reach, the vehicle will come and we can avail onto it. It's not like that. It's like a target shooting. So exactly at that moment where we anticipate the moon to be, if we can reach out to that place, then it's fine. We get into the moon. Or if it is a mishap in the calculation, the moon goes away in its own path and we go inside the deep space without any without any place to stop, and we are lost forever. We are gone. So actually, it is almost a task like, say, shooting a coin blindfolded from a distance of 10 kilometers. And the chance, you know, that the chance of the projectile hitting the actual target is so low that here also, in this case, it was that difficult a task. So the first requirement to immediately understand it here, that we need to understand the dynamics of the Earth and moon's motion very well, so that we can calculate their path absolutely accurately. and then send the vehicle there, because life cannot be played with. We cannot take any risk or chance of our astronauts who are fantastically trained to take up these jobs. So naturally, the precaution would be very, very high before we can really attempt to go there. And that was the case. And slowly we'll get into other details of it. So now you can understand that it was a pretty difficult calculation on paper itself. Even before trying the engineering, on paper it was a very difficult concept. And you'll be astonished to know it was a time, 1951, when the computers, I mean big computers, the computers were not these small which can stand on everyone's desk. They were just coming up. Their processing power was much, much lower, and the electronic chips were just discovered. It was not very old, and the situation was people were in great jeopardy, because if you have to honor this mission of going to the moon, you need a lot of things. You need to calculate a lot of things for which the technical support was still missing. And NASA, the organization which actually pulled up the Fiat, they had a group of ladies who were all mathematicians, led by one great lady named Catherine Johnson, who was a mathematician and a fantastic mathematician at that, who actually was in NASA, was a very male-dominated organization to start with, and Catherine Johnson was one lady in that. She had many difficulties there, but still she led a group of ladies, and this group of ladies were called computers, very astonishingly. And why so? It is because these ladies were given the special task of not only doing the calculation for going to the moon, the orbit, but also all sorts of spacefaring calculations. The calculations were performed by hand by people, and these were the people who actually did that. So they were called computers. And Catherine Johnson was so very famous that while going to the moon, the whole crew, they approached her and they wanted to know how sure she is about her calculations, so that the astronauts can be sure of their life and they can rely upon it, because it's a question that big. So they asked this question and expressed their concern about it. And what Catherine Johnson says is very, very interesting. She said, "Go there and the moon will wait for you." That is how confident she was about her calculations. And later on, in another very important engineering point of view, after landing on the moon, there was a follow-up project. There are a few more projects in which man have further landed on the moon, and many more people have gone there. That's a separate story altogether, but the first landing was given extraordinary importance because that involved a lot of things. The later on, I mean, the next attempts were a little comfortable in this sense. Then we knew what to do, and we knew what did we do wrong, and we had the scope to correct it. Even then, one particular mission that went wrong, and the mission had to be aborted. And when that had to be aborted, Mrs. Johnson was called up once again, and she came back and she had to recalculate the whole path, because the vehicle had to return to Earth. It did not have enough fuel to do so, because there was a burnout situation. One particular valve was not working, and that is why it lost a lot of fuel there, and there had to be an alternative method, and she found out an alternative method of using gravity to pull it back, and that was arranged. So and finally we could not I will not say we, but finally mankind could save its astronauts, and they were safely landed back on Earth again. So you can understand that it's a pretty much difficult, challenging, and very, very critical calculation that goes while doing the actual stuff. Now, the less than 500,000 kilometers, I told you 4 lakh kilometers, about that's the distance. If you take the brute force, that from Earth you have to start straight away and go to the moon without going any detour or without waiting anywhere, which is anyway impossible, then it will take about 3 days. It's a 3-day journey. And what is the best possible propulsion fuel that we have that generates the maximum amount of energy very fast so that we can use it for going to the moon? And still that energy has to be under control, because uncontrolled energy cannot be used for any purpose. It will burn up everything. So the best possible bet that we had was the hydrogen and oxygen mixture. It can generate huge amount of energy because we need to get over to the pool of the Earth. And that is why when we started thinking about going to the moon, this was the propulsion fuel. But the propulsion fuel is not that simple. That I said that it is hydrogen and oxygen in gaseous form. It is taken. It is not taken. Probably it is taken in the solid state to reduce the volume so that we can carry maximum amount of fuel. We will see why we need huge amount of fuel there. And apart from that, there are other technologies of preparing this fuel which every country guards very strongly. No one exposes what their exact technology of the fuel is. So, well, that is one thing, you know, that firstly you need calculations, secondly you need an appropriate fuel so that you can generate a speed of 11.2 kilometers per second and a little more than that to go out of the bounds of the gravity here. Right? That is the challenge. Now, the question, why do you go there at all? What is the purpose? I mean, why do we need that? The question is, the equipment that keep you alive there on the moon, and all of them have serial numbers because they are very, very important. Spare parts there are very, very important. And then it starts from 001 and that goes on like that. We know the relevance of spare parts while we were making the International Space Station. It took 19 years to make this space station, and once you reach out there and you think that this time we have forgotten this spanner and we have to bring it next time, you have lost a huge amount of time. And that is why marking of the serials and maintaining them, it's a management problem as well, where the material management becomes extremely important to carry out such a mission. And then the question is resupplying hydrogen and oxygen. If we go to the moon, that can be easily resupplied on the moon, so there can be further motion, outbound motion from the moon itself, and that is why moon is an interesting object. And a launch window from moon, if you have to go out, you will find out that from Earth, if we have to go out, we have to wait for the opportune moment, appropriate moment. If you follow any of the launch operations, so when ISRO announces them, you will find out that there is something called a launch window. This launch window is necessary because we need the appropriate moment, starting moment, when the Earth in its motion on its orbit and on its spinning spree is at the right position, at the right moment, when it can sling up the vehicle to the right direction. And that is called a launch window. So we have to wait for the launch window, and we get few of them on Earth. On Moon, we can get much more, many more of these launch windows, and probably a few in a week. And that is why it is more interesting to go to the Moon if you plan to go even further outside. And the Moon is interesting. The Moon is interesting because the Moon preserves the history of the Earth. The Moon and Earth were built and created at the same time. But on Earth, the geology has wiped out all the necessary signs of the early Earth by now. We have changed quite a lot with the environment and other things. Organically, we have evolved, but Moon has still preserved it because there is a much less abrasion on the Moon, the much less effect of the weather and the water, and they cannot change. So naturally, it is there. So to know about the early Earth, we need to go to the Moon. So that we know what really it was like at the very beginning itself. And the fractional gravity is a great help that we will see later on. But let us go to that condition now. Yes, and very recently we need to carry, yes, if we have to work on Moon, if we have to put up a station over there, we need to carry a lot of materials, bricks, cements, mortar, glass, etc., etc., powder for 3D printing simulators, so that we can build other things over there itself. But to do all that and to create all those things on the Moon, not create, I'd rather say extract all those things on the Moon itself. Moon has got a fair share of its minerals and other natural material which can be shaped into it, and we now know that it's basic chemistry which can be performed on Moon to achieve all that. It's not very difficult. The necessary materials are available there. If we can manage to make up with oxygen, hydrogen, and then the other things can be arranged there. We have abundance of solar energy, and our own vehicle Chandrayaan, it has discovered that there is water on the Moon, though not in the liquid form. It is in the solid form. At the poles there is water, so that can be mined and that can be used. So altogether, the chemistry is not very difficult. Doing the chemistry there is possible, but there would be other challenges of doing it. The question is, in Moon, that is what I wanted to stress upon, that even the 19th century industrial chemistry, what we knew at that time, with that the melting, smelting, sintering and other, that means the Romans, the idea that Romans had in their period of glory, they could have pulled out and produced brick, cement, mortar and fuel, hydrogen and oxygen for further spacefaring on the Moon itself. So that is possible. That's a possibility, and that there is a possibility of camping on the Moon makes Moon more interesting for the scientists to go there. So there will be engineering problems, of course. There are other engineering problems. I'll get back to it. Because of the fractional gravity, the chemistry is understood, Moon becomes an interesting target. Now let us slightly concentrate upon what it takes to go out of the gravitational pull. It's a very, very big pull. And one scientist, his name was Tchaikovsky, he created one equation. It's called the rocket equation. And the rocket equation is very interesting. Suppose this is a rocket. This is not. This is a caricature of the rocket, a very badly drawn rocket, you must say. But even then, just think of it as a rocket. And if you plug in two numbers inside the Tchaikovsky equation, one is what is the magnitude of gravity that you are going to overcome with your vehicle, and number two is what is the type of propellant that is your fuel, that is how much of energy it can generate. If you can plug in these two numbers into the rocket equation, the resultant is what it gives back to you is how much percentage of the total vehicle must be full with propellant. Right. And that is an interesting calculation, very, very important. So if you have to create a rocket that can go from Earth to orbit outside into the space, into the real space, it can be seen that 85 to 90% of the rocket must be filled with propellant and the fuel only. So for taking other things and other instruments and all, whatever you see, that big structure, this inside it is full of fuel, and all other things they make up only 15% of it. The rest inside is fuel and fuel and fuel. So if you collect up so much of fuel in one place and if you burn that, you know it is almost like a bomb really. So if anything goes out of hand, there is a possibility of a huge explosion. And that is why the propulsion has to be 30% of the fuel you can make a journey out of the moon. It can be a controlled journey over there. So that shows that the rockets are no longer completely like bomb. You don't have to spend up all the fuel and discard the rocket altogether. From moon, you can go out with 30 to 40% of the fuel, and you can make a journey like you are moving in a plane, and you can return safely in with the same vehicle and reuse the vehicle, which is an important criteria for going out to space from moon and the earth. Any issue? Well, so that is what it takes to go to the moon, and it is 15%. That 15% is very, very important. So you know what was the challenge there, and the strategy was exactly like that, what I said, that goes straight back. But now if we have to go to moon and stay there, we need to create an elaborate mechanism. We need to create a closed structure. And when these people went to the moon, very interestingly, we did not even know what sort of dress should we need, because the moon doesn't have the cover of the atmosphere, and all the harmful radiations, they are always falling on the moon. And probably you know that there is one huge dry ocean in the moon that had a diameter close to 3,000 kilometers, and it happened because one asteroid hit it up straightway on the face and created such a deep and big crater. And on Earth it is very unlikely, because the Earth's atmosphere, when other meteoroids and asteroids, they get into the environment of Earth, they burn up because of the friction with the atmosphere. And the atmosphere also prevents the harmful rays coming from the outer space, but it is not so on the moon. So you are exposed and you need special suits, and that is why the space suits came up. And let me tell you something very interesting, that when people thought of going to the moon, they did not even know how this dress is to be made. So there were several experiments, there were several issues that came up, and there was a global competition to make that dress even, and one particular company, they won it, and they created the dress, which was tested, and there are more than 30 layers in that dress to give it the appropriate supple yet safe and strong enough protection to the person who is wearing it. And even folding the space suits, they needed special skills, and only 3 persons they knew how to do that, and that is why all 3 of them were always taken to any other place in separate vehicles, so that no such accidents can occur, and or kill all of them. At least one of them should be alive. To maximize that chance, they were always taken separately in their own car. I'll just play you a small video to show what it takes to make an arrangement on the moon, a camp on the moon. Just watch it a little and you will understand how the life would be if you have to be on the moon. It is interesting. Suppose you wake up in the morning and from the bed you jump out, and the underground existence, the water goes down, and that water is watering the vegetable garden, and all that self-sustaining arrangements are to be made under closed system.
It's been for the last 12 days. This isn't some post-apocalyptic scenario. It's just another day of life on the moon. And with the European Space Agency's idea to establish a functioning moon camp by the 2020s, that day may be closer than we think. Of course, living on the moon won't be easy. The camp envisioned is not so much a village as an inhabited research base, similar to those in places like Antarctica. But there are far greater obstacles to living on the moon than just cold weather. The biggest is cosmic radiation. Unlike the Earth, the moon has no atmosphere and no magnetic field. A person on its surface can receive over 400 times the maximum safe dosage of heavy ion radiation, enough to be fatal within 10 hours, even in a spacesuit. The first step would likely involve robots and 3D printers constructing covered habitats from lunar soil, or building shelters inside caves formed by lava tubes from the moon's volcanic past. But what would the inhabitants live on? Supplies would need to be transported from Earth at first. Growing plants requires greenhouse soil and air rich in carbon dioxide, a gas that's rare on the moon, but could be synthesized from recycled materials. A water treatment plant could be supplied by ice mined from the polar regions, using a specialized drill that can bore 2 meters beneath the lunar surface. Friendly bacteria and viruses necessary to the human microbiome and immune system would also have to be imported or synthesized on site. And lunar inhabitants would have to exercise for hours a day to maintain bone and muscle mass. That's because the moon's gravity is just 1/6 that of the Earth, and the everyday strain of working against gravity is part of what keeps our bodies healthy. It might seem strange to go to all this trouble to build a base on a dead rock we've already visited, but NASA's Apollo missions only explored small portions of the moon. We've made many discoveries since then, such as ice near the poles and particles of solar wind gases that date back billions of years. They collectively show that the moon has much more to teach us about the history of our solar system. A radio telescope on its far side could observe the cosmos, shielded from the Earth's electromagnetic interference. And the lunar surface is rich in minerals like silicon, aluminum, and magnesium, creating great economic potential for mining. But the biggest benefit of the moon camp may not lie on the moon, but beyond it. With the nearest possibly habitable world light years away, and the International Space Station to be retired in about a decade, a moon base would be our first foothold towards becoming an interplanetary species, and proposals such as the Deep Space Gateway envision launching future missions from lunar orbit. The smaller gravitational pull would require less fuel to overcome, allowing for larger ships and more cargo. Meanwhile, the base on the surface could serve as a testing ground for future space operations, a refueling station, and a supply depot all in one. With Europe, Russia, Russia, China, and the US expressing interest in the project, the moon camp may come to involve the space agencies of all major nations, as well as private companies. Within a few decades, the moon may be bustling with mining operations, research stations, and tourist routes, alongside a construction yard under an orbiting spaceport. We may have already visited the moon, but now we're closer than ever to making it part of humanity's home.
Okay, so that is the imagination. Now it is a more practical imagination where we know the planning, where we know what to do. But by this time you have probably understand that I'm sorry, not 51 to 59. It is from 61 to 69 that this whole project ran up for landing on the moon, and it took the help of several scientists, engineers, factory workers, artists, designers, and all that. And what was the cost like? The cost was initially 1 million in first year was allocated to this project. But 5 years down the line, $1 million was being spent every 3 hours in the project. And did the Americans support it altogether? No. The question was that even at the topmost support for this project, only 39% of the Americans, they supported it. But the authorities and the management there and the scientists, they carried out the project and ultimately landed up to this huge success. But you can understand that that legendary single step actually required million steps to support it, so that the moon landing could be a possibility. The success is the very age we live in now. The race to the moon did not usher in the space age, of course, but it ushered in the digital age of real-time computing. It is because when we had this project and we were crafting the necessary equipment, we understood that electronics would be extremely important, and that is why slowly the question of using the latest of electronics came up. The computation power enhancement was a huge requirement, and that is why from there it started the electronic age altogether. The first chips were used in all these vehicles and planets. The computations became vital for such projects, and we understood that whatever is the challenge in the mission, we can rely upon our electronics to give the appropriate basis for attempting all such things. And that is why from there our reliance on electronics increased, our reliance on computing increased, and it launched into the digital age. Yes, till today we are not really going space on every other day, but we are using all those offshoots of these space attempts there, and that is why it is becoming very, very important. I discussed the method of going to the moon. Here you can see that in appropriate launch window the vehicle goes there, but even then there are several steps involved. There are several parts in the vehicle which slowly gets stripped off, and ultimately a bare bone thing reaches out to the moon, which once again rotates around the moon, and that too separates out into two portions, and only one portion lands on the moon, the other one orbits through, and after doing its experiments and performing whatever tasks are cut out to it, the other part once again launches from there, and it reaches out to the orbit where the other part was moving around, the orbiter was moving around. It joins there, docks in both of them, and then they return to the Earth yet again. So it's a very involved maneuver, and that takes a lot of effort. In our particular method that we adopted from ISRO, however, the concept was a little different. It was not that brute power reaching to the moon. We used the gravity sling, and here in this small introductory video, you can see what technique ISRO used to go to the moon and coming back from there. Here is the ISRO vehicle that you can see, the launch vehicle. This is an animation. This is a complete plan that was made into place to reach out there. But the technology and the technique you can understand from this video. This is the liftoff. And while going on to the space, slowly the other parts of the rocket, they are getting stripped off, and it is reaching out for the absolute space. And then it opens up, and the loads, they come up, they are now open, and this is the bare bone structure that will go up to the moon. Right? Slowly, a smaller part, only these two parts will go there. Now their solar flaps will open up, and the technique that we used was we orbited multiple times the Earth and increased our velocity. Slowly and slowly, it increased the orbital length as well, and then only, like sling, it was thrown by the gravity to the absolute outer space. And while it reaches to the moon, it gets into the gravitational pull of the moon, and there it starts rotating around the moon once again. Here you can see how it is happening. It turns, its proper direction is to be adjusted for the orbiter. Then it will split into two parts, and one part will go towards the moon. And just before landing, its camera scans the whole space, looks for the appropriate place because it's an unknown terrain. So it will scan the whole thing, find out where the craters are, and decide the space where to land up on its own. And we expected a soft landing there, but this time we could not really perform the soft landing. And that is why we are looking for a follow-up project, and we expected that once our vehicle is landed up, its inclines will open up and the rover will come out and the rover will move on to the moon. This time it could not have happened, but next time definitely we will be successful perhaps, and we can perform the feats that we are needed to do to go on and on in search of new camping positions on the moon itself. Right? So this is the current condition, and with that, I think I must end up here with this presentation. Thank you very much for hearing. That is the moon, and that is what it takes to kiss it, as you have given the title in your program.
Yes, thank you, sir. Thank you, sir. Now, anybody having any questions related to this thing, physics or anything, you can ask. Yeah, sure. Sir, can I?
It is an absolute nonsense. These types of gossips will always be there, and they're complete nonsense. It is because there are thousands of proofs that actually it happened. And this kind of stupid theories are coined by people who have nothing else to do. Let me just answer that why it is impossible. The flag that they show up, they have no real uh, clues actually what happened. The flag was on a L type of stand placed like this, and it was stretched with it so that it can stand there. But naturally, on such a long journey, it was crumpled, and that is why it looks bumpy. There was no air flapping, and it was not flapping. It was just stretching, and they got the image like that, and they tried to create suspicion. These are all called conspiracy theories. They always try to create suspicion in the minds of the people, giving some wrong clues, and it is a wrong. The biggest proof that it actually happened is the whole journey was logged. Logged in a sense, during the whole journey, the base station and the vehicle, they communicated to each other. And those tapes, those details, they're all available. They're preserved. They're museum material. So one can check that and always can confirm it is a real thing. It's not a gossip.
Thank you. Any other questions?
Sir, when will we reach a time when we can use this atomic reactors in rocket other than fuel?
Very difficult prediction to make. I do not know. I have no idea when it could be possible. There are several challenges for it. People can work on it. To have a better fuel is always a better idea, but no time limit as of now can be set, I suppose, and there is no such target even. There are some small experiments, but there are so much of risk in it, and there are so much of engineering problems there. It is almost abundant, but still some experiments are going on. So I'm not sure. Apparently, it looks very hopeful that if we can do that, we can get into it. But as I showed you, that the engineering problems involved in such endeavors are huge, and they are not easy to overcome. So I cannot give any time limit, a practical time limit to it right now.
Sir, can you say to these students, what are the opportunities and what are the arena of after 10th standard, after 10th or 12th standard, they can venture on in these areas, in your concerned areas?
See, it doesn't really happen like that. We in India, we have a very strong organization called ISRO who looks into all such issues and who controls our space projects. And to join ISRO, if you go through our YouTube channel, then there you will find out that the senior most engineer of ISRO, Dr. Somnath, we had a program with him. He had a long lecture there. It is still kept in our channel. You can see it at any point of time. And he explained something very nicely. He explained that ISRO needs engineers, ISRO needs scientists, and if you are well with your endeavor, if you are a good electronics engineer, mechanical engineer, if you are a good physicist, if you are a good chemist, all have possibilities in ISRO, and you can approach that after you complete your degrees. There are several exams that ISRO takes, and ISRO also has its own institute where you can join in by qualifying through their own exams. But he also interestingly mentioned another thing: the subject doesn't matter, because once you are in, you will be trained into all possible subjects. He said, I was a mechanical engineer, but I do more electronics than mechanical engineering these days. I do physics all along. So everything has to be learned once you are in, but to get in, you must be very, very good in your own discipline. And he also mentioned another very interesting thing with a little smile that we also have a director in ISRO whose basic subject is fishery. So you can understand that the opportunities are many if you work with your subject well, and if you study well, then you can always appear for their entrance exams and get into these efforts.
And anybody else? Any questions?
Sir, what is inside the black hole? Is it five-dimensional, a theory?
I do not know. Neither have gone there nor have any idea what can be
These
there. I have
people.
not seen
What
any
about the
scientist
theory?
still predicting it. There's no theory. The theories that you are talking about, they're all nonsense, mostly written down in some figments of imaginations of science fictions. There is no such strong theory which predicts that there can be something still now inside the black hole.
Yes, thank you, sir. Just give some message for them for the future, actually, and we can wrap up this program.
The message is always the same, and I wish you all the best. I have an urge to make. The last question actually prompts me to do that. Read science as science and not as a story, and not as imagination. Please keep away from all such nonsensical and romanticized spacefaring. And if physics is not like that, that there is a 5-dimensional, 15-dimensional theory, all on a sudden certain mad scientist will discover something and all together everything will change. It doesn't happen like that. You have to know your maths very well. You have to know your proper theories very well. And real scientists and real physicists are not bothered with such problems. Science does not happen that way. Einstein still considered the matrix to be dealt with. He still had the relativistic equations to be solved. So there are many popular writers. Please do not study science from the popular science books. Read it from the science books, and that is the message. And if you really want to learn it, learn hard, concentrate upon it. I wish you all the best and all the success in life.
Yes. Now the last one, the vote of thanks for him.
A very warm good morning to all. It gives me an immense pleasure to deliver the vote of thanks for this event to all dignitaries present here. First of all, I would like to thank our speaker and chief guest, Manash Bagji sir, curator and project coordinator, Regional Science Center and Planetarium, for his informative and enlightening words. Thank you, sir. I would like to thank our beloved principal, Reverend Dr. Biju Janvelakada, for his presence throughout the webinar. Thank you, Father. I would like to extend my gratitude to Binay sir for giving us such an opportunity. Thank you, sir. Last but not the least, I thank all my friends for making this program a grand success. Thank you. Once again, I thank all of you present here. Thank you all.